Welcome to Study Loop.
This is the answer to Chapter 13, problem number 12 from the Smith Organic Chemistry textbook. And this problem is asking us to make three comparisons between different kinds of light and to determine in each comparison which light is going to have the higher energy. And so to answer this problem, we need to remember that energy increases as frequency increases and as wavelength decreases, and conversely, energy decreases as frequency decreases and wavelength increases. And so over to the right in blue, I've drawn some pretty poor representations of waves, if that helps you remember. So, given that wavelength is the same at a higher frequency, you're going to be packing more waves into a given space, and so you'll have more energy. And so for A, we're asked to compare light with a frequency of 10 to the 8 hertz and light with a frequency of 10 to the 4 hertz. And so if we remember that as frequency increases, energy increases, they're directly proportional. So 10 to the 8 hertz is a higher number than 10 to the 4 hertz, and therefore the 10 to the 8 hertz will be the higher energy light. So B is exactly the opposite. Remember, energy decreases as wavelength increases. And so 100 nanometer light, or light with a wavelength of 100 nanometers, and remember nanometers means 10 to the negative 9 meters, is going to be higher energy than light with a wavelength of 100 micrometers, because micro means 10 to the negative 6. So 10 to the negative 9 is a smaller number than 10 to the negative 6, and therefore it will have higher energy. The smaller the wavelength, the higher the energy. To answer part C of this problem, you need to know about the visible light spectrum. And so over here to the right, I've drawn the mnemonic that I was taught to remember the order of visible light. So it's Roy G. Biv, like a guy's name. That's what I was taught, Roy G. Biv, and it stands for red, orange, yellow, green, blue, indigo, violet. And so red is the lowest frequency and the lowest energy. Violet is the highest frequency and the highest energy. And so if you know that, it's pretty easy to see that blue light is going to be higher energy than red light. And so that is the answer to Chapter 13, problem